Ever wondered how artificial neural networks work? Well, it's time to explore the fascinating world of feedforward neural networks, or FNNs, a fundamental type of artificial neural network that forms the bedrock for many other neural network architectures. Imagine a structure of interconnected artificial neurons, also known as nodes or units. This structure makes up the architecture of FNNs, comprising three main types of layers: an input layer, one or more hidden layers, and an output layer. But how does information flow through this network? The key characteristic of FNNs is the one-way traffic of information. It starts at the input layer and ends at the output layer, without any detours or U-turns. The output of one layer simply becomes the input to the next layer, and this process continues until it reaches the output layer. Now, let's move on to how each neuron in an FNN processes its input. This is where activation functions come into play. Functions like the sigmoid function, ReLU, or the hyperbolic tangent introduce nonlinearity into the network. This allows the network to learn complex patterns and relationships in the data, making it a powerful tool for understanding intricate datasets. Training an FNN involves supervised learning. The network learns to tweak the weights and biases associated with each connection between neurons to minimize a predefined loss or error function. This process involves two main steps: forward propagation, where the network computes predictions, and backward propagation, where it updates the weights via gradient descent. So what can you do with an FNN? They are commonly used for classification tasks, where the goal is to sort input data into predefined classes or categories. Think image classification, sentiment analysis, and spam email detection. But that's not all. FNNs are also handy for regression tasks, where the goal is to predict a continuous numerical value, like predicting housing prices or forecasting stock prices. While FNNs are versatile and can approximate a wide range of functions, they do have their limitations. Capturing long-range dependencies in sequential data, such as natural language processing tasks, can be a challenge for FNNs. For such tasks, more advanced architectures like recurrent neural networks and convolutional neural networks are better suited. To wrap it up, feedforward neural networks are a fundamental type of artificial neural network with a simple, layered architecture where information flows in one direction. Widely used for classification and regression tasks, they serve as the foundation for more complex neural network architectures. So the next time you marvel at the capabilities of artificial intelligence, remember that it all starts with the basics, like FNNs.